Today we are going to talk about two surprising limits in geometrical problems. This video is based on the article published in 1982 in the Mathematical Gazette journal. I'll put a link down below. Imagine you have a circle with radius equal to 1. Starting at point B, you draw a chord with length L and also a perpendicular line with the same length L. Then you connect the two ends until it intersects the horizontal diameter at point E. Now we want to know what happens to E when L goes to 0. Pause the video if you want to give it a try, and when you are ready, keep watching. Okay, let's calculate the length BE. First, we name these angles alpha and beta. The small triangle is isosceles because it has two equal sides, so we have two equal angles beta. Now check this yellow long triangle. Length BE is equal to BD tangent beta, which is equal to BC tangent pi minus alpha divided by 2, because beta is half of pi minus alpha and BC is equal to BD, which you can simplify as BC times cotangent half alpha. But how much is BC? If you look at the chord BC, you can see half of the central angle facing the chord BC is again alpha. That means BC is 2 times of the radius times sine alpha. If you simplify, you end up with BE equals 4 cosine square half alpha. Now, when L goes to 0, alpha also goes to 0, which in this case BE approaches 4. This is not what you could have expected, because most people say point E probably approaches point B, or maybe point E goes to infinity. That's why it's kind of an interesting and surprising limit. Now let's change the problem a little bit. This time, instead of a chord with length L, we have the arc with length L. The arc BC has the same length L as the perpendicular line BD. And again, we want to know what happens to the point E when L, or the length of the arc, goes to 0. Are we going to have a different result, or we still gonna have BE equal to 4? The first thing we do is to drop a vertical line from point C. Then you can see we have two similar right-angled triangles, which you can write this equation for them. That's the ratio of their sides. BE divided by BD is the same as PE divided by PC. Now notice that the angle facing the arc with length L in a circle with radius 1 is again L, because that's in radian. Using that, you can say that in this yellow triangle, because the hypotenuse is 1, the other two sides are sine L and cosine L, which you can use to modify the equation we had into this. From that, you can find BE as a function of only L. Now, when L goes to 0, this goes to 0 divided by 0, which is a problem. We don't have an answer. But we can use the L'Hopital rule and continue with the solution. That means we take the derivative of the numerator and denominator, and then we check what happens when L goes to 0. That's when we apply the rule. Problem is we still have 0 divided by 0. So we just repeat the L'Hopital rule. This is another time, and then one more time. And now we have something different from 0 divided by 0, because you get minus 3 divided by minus 1, which is equal to 3. This is different from the result we had in the previous case, which is again surprising, because the problem is not that much different from what we had before, and of course we couldn't expect a different result. Mathematics is always full of surprises like these. I hope you enjoyed this video and thanks for watching.